This question is on radioactivity, and you are given a beam of radiation enters a region of a strong uniform magnetic field into the paper. Now, how do you know it's into the paper? Because this region is magnetic field and they are represented by crosses, meaning to say it's into the paper. All right, and if it's a dot, it will be out of the paper. And it's also given that the beam splits, one into a curved path and the other is a straight path, and it's as shown here. So this is curved and this is straight. Let's recall the three types of radiation, and you have your alpha, which is a helium nucleus, which is positive charge +2, and you have the beta, which is basically an electron, which is -1, and lastly you have your gamma ray, which has no charge because it's just an electromagnetic wave. Now let's take a look at this beam here, and because it's not affected by the magnetic field, you should know that it must be your gamma radiation over here. Because it has no charge, it will not be deflected by the magnetic field. Next, this beam here, if it curves upward, that means to say there's a force acting upwards towards the top of the paper, and because a charge, it must have a charge, and charge is moving. That means to say you have your current and there's the magnetic field and there's a force. You should be using your Fleming left hand rule. Now this is how you should position your Fleming left hand rule, and there are two things that you know that will lead you to this position. Is because the beam is deflected upwards towards the top of the paper. That means to say there's a force acting in this way. So the thumb, which represent the force, will be pointing perpendicular to the path like that. So it's upwards. And another thing that you know is the magnetic field that's into the paper. So the first finger, which represent the magnetic field, will be pointing into the paper. So that leaves with the second finger here, which represent the conventional current. And since conventional current is going this way, and conventional current is a direction in which a positive charge will take, so this is a positive charge going this way. In other words, that will be your alpha particles. So the answer for this question will be B, alpha particles and gamma radiation. You might wonder, what if there's beta emission? And the path usually will be the other side here, and it will bend more, all because of the electrons is actually very light, so you'll be deflected more by the magnetic field. So your Fleming left hand rule should be positioned like this. I hope, I mean, it's a bit difficult to see, but I hope you can. So likewise for this, you know that because it's deflected downwards, okay, the force must be downwards here. That will give you a hint where to place your thumb, pointing downwards, so it causes the beam to go down. And the magnetic field likewise is into the paper, so make sure this finger, the first finger, is really pointing perpendicular to the paper, into the paper. All right, so the second finger, which you can't see, is being blocked because the fact that this is in 3D like that. So the finger is pointing to the left. That means your conventional current is going to the left. And if you can recall, if conventional current and electron flow is opposite, so the electrons must be flowing this way, and if it's negative, so it's negative since the beam is moving to the right. That means to say it must be negative charges, and the only negative charges will be beta particles. All right, so I hope you understand this question now. Thank you.